Algebra 2. So this is our first video lesson that you are watching on your own. So we're going to start chapter 8. We're going to do the first two sections, which is really like an introduction to the chapters. This chapter that's pretty easy. So I'm just going to kind of do this as if you were here, but I just don't get your participation, which is a little sad. But I do want you at times to try to pause the video and think for yourself. So like when we go through these questions, first try it on your own, pause it, then see like what did you think compared to what I do. So I do want you to try to pretend as if you were interacting in the class, like what would be your side of participation. Because if you just watch this video without doing any thinking on your own, you're not going to learn it, okay? So make sure like you pause it throughout and try to think on your own before I explain, okay? So we're going to start with an example of direct variation. So this is just, a nice real life thing. So Miss Jones, she loves strawberries. This is a true fact. And at a farmer's market, someone purchases 5 kilos of strawberries and pays 67.50 lira. She wants to buy strawberries too, but she wants only 2 kilos. So we want to know how much would she pay. So we want to find the solution just not through some formula or about trying to be all super mathematic, but let's just think if we were there, like what would we do? So my instinct would be, well, let me find out how much it is per kilo. So what I would do is take 67.50, that looks like an 8, but it's a 5, and I would divide it by 5 because that's how many kilos we're getting, which tells me 13.5. So that tells me how much lira it is per kilo. But we want to know how much it is for 2 kilos. So if I take the price per kilo and just multiply it by 2, we get 27 lira. So we're kind of finding like the unit rate in this situation. So let's think of an equation that if we wanted to find the price for any amount of kilos, what would it be? Well, pretty simple. Just like here, I multiplied the number of kilos by the price per kilo. So no matter what, if it was 10, 15, 20 kilos, I would always just multiply that by 13.5 because every 1 kilo is 13.5. So an equation then could be y equals 13.5x. So 13.5 price per kilo or the unit rate. X would be the number of kilos. Y would be the overall price. I hope that's a nice review from back in the day of linear equations. So if the price changed, how would that affect your equation? Well, this is the price, so that would be the only thing that would change because still the number of kilos in the price, that part still remains. So we're just going to make up some variable, and this has a fancy word called constant of variation. So just a fancy term, this is just the general form of direct variation, y equals kx. So this is kind of what signifies direct variation. So we want to know just what's happening between the two things, the price and the number of kilos. So as the number of kilos increases, well, so does the price. As the number of kilos decreases, like if I bought less strawberries, well, then the price also decreases. So if we were to create a table, so just put in some values for x, the number of kilos we would get. I'm hoping if you think of linear equations, think about what does that look like in a table. So I could just plug in 0, right, into x. Well, if I plug in 0, I get 0. I could plug in 1 and I would get 13.5. I could plug in 2 and get 27. But if you remember with linear functions, I have that constant of addition or subtraction. So every time I'm just adding 13.5. So that's another way, instead of just plugging in, you could use the idea of a linear function. So graphically, I could plot points, but we know it's just going to be a straight line because it's a linear function, has slope. So this situation represents direct variation, as I said. This is what signifies direct variation. as one amount increases or decreases, the other amount does the same. So if one increases, the other increases. If one decreases, the other decreases. Also, we say that these two things are directly proportional. So the amount of kilos and the price are directly proportional to each other. And when I say price, I mean the total price, not the price per kilo. So maybe we should signify that. Total price. Okay, so let's go back to the table though and think, like, is there something going on that if I were to just look at the table, I could determine that it is direct variation? So I can't just think, oh, I add 13.5 every time, because that tells us a linear function, but it doesn't necessarily tell us direct variation, because a linear function could be like kx plus or minus something. But this direct variation doesn't have any plus or minus stuff. So I can't solely rely on just seeing if there is addition or subtraction change. But I still want to think, is there a way to get this 13.5 that I could like somehow find the constant of variation? So try to pause the video and think of that. Like, is there a way by just looking at the table that I could find the constant of variation? So the way that we can see that is if I divide y and x, so if I did 13.5 divided by 1, 27 divided by 2, 40.5 divided by 3, 54 divided by 4, that all gives me 13.5, which basically if I solved this equation for k, I would get y over x is k. So this is how we can determine if it's direct variation, is if we divide the y and the x. If it gives me the same number over and over, well, then I know it's direct variation because there's this constant of variation specifically for it. Okay, so that's just one way of just determining direct variation from a table. So now let's move on to our next situation. So for a pizza party, you have 48 slices of pizza. Each person is going to get the same amount of pizza, but no one has RSVP'd. So if 12 people come to the party, how many slices of pizza do they get? So if there's 48 slices, 12 people come. I'm hoping that you could figure this out mathematically. I would divide. So if I divide 48 divided by 12, each person would get 4 slices, not too shabby. Let's write an equation. So just like last time, we kind of looked back and saw, oh, we multiplied by the number of kilos. That's why I did 13.5 times x. But in this case, this time we divided. So the thing that would be changing would be how many people would be coming, right? Because that's what determines how many slices each person gets, is how many people come, because that 48 is already determined. So our equation would be 48 divided by x, where x is number of people, y would be number of slices each person gets. Okay, so that 48 represents the total amount of slices, or basically I can think of the amount that's gonna be split up. So if I change the number of slices, how does that affect your equation? So 48 is my number of slices, so just like before, we'll make up a variable. And guess what? This one is also still called the constant of variation, because both of these are variation situations. The first one is direct, this one's called inverse, but both of them are variation. So k still exists, but just in a different way. So now let's think of it this time, the same situation as before. What if I increase the number of people going to the party? And what if I decrease? So if I increase the number of people, what happens to the number of slices? Well, you get a smaller amount, right? If I have more people, well, we still only have 48 slices to begin with. So yes, if I have less people, well, then you're gonna get more pizza. So this one's different from direct. Direct, both increase or decrease. This one, it's one or the other. So let's look at a table. So I can't put in 0. So I want you to think about why that's true mathematically and with the situation. So 0, doesn't work out. Because if I put in 0, well, 48 divided by 0, I can't ever divide by 0. And it doesn't make sense to have 0 people coming to the party when you already bought pizza. You know somebody's going to come, you know? So we never have to plug in 0 for inverse variation. Let's say one person comes. Well, they get all the pizza. If 2 people come, they get 24 slices. 3, 16, 4, 12. If I were to graph this, so if I have 0, well, there's no way I can plug in 0. So there's never going to be something on the y-axis. So we can pretend at 1, 48, then 24, 16, 4, and it will continue like this. So just like before when we were talking about exponentials and stuff, like these graphs also never cross the x-axis, also the y-axis. I think we will get into discussion of why. No, we won't, so we'll talk about it now. So no matter how many people come, like I'm never gonna have 0 slices of pizza, right? It can always be divided. So I'll never reach 0 on the x-axis or the y-axis because I'll never have 0 amount of people and I'll never have 0 amount of pizza. You'll always have some slice of a pizza to give, even if it becomes like 1/10 of a slice. That is still in existence. So these graphs don't cross the x or y-axis. So as I said before, this is inverse variation. Just described here as one amount increases or decreases, the other does the opposite. So while you're watching this, if you do have questions, please write them down because when we do our live class, we'll practice this section, but it will also be a time for you to ask your questions. So if you're like, I didn't really understand what you meant there, like ask that. We'll start with all the questions that you have. I'll try to answer them and then we'll practice. But please write things down. Don't forget so that you can ask them when we do our live class together. Okay, flipping the page. So looking at the tables, we're going to determine is it direct, inverse, or neither. So actually, let's go back and look at our inverse variation table. So again, we want to think, how could I figure out what the constant of variation is? Is there a way that like I can look and see, oh, this would be inverse variation? So I want you to think about that. So what we can do just like last time is solve for k. So that relationship with k, if I brought over the x through multiplication, if I multiply x and y, I get the constant of variation, which let's check. 48 times 1, 48. 24 times 2, 48. 16 times 3, 48. 12 times 4, 48. So for direct variation, I was dividing y and x to find the constant of variation. For inverse, we're multiplying to find the constant of variation. If you ever forget what to do, just think back to the general form of the equation and solve for k and then do that in your table. In this case, multiplying x and y. So let's look at that here then. So I basically want to decide, is it inverse or direct? So either I'll divide y and x and see do I get the same thing, or will I multiply y and x and get the same thing? So since I'm seeing 2, 15, 10, and 3, I know that multiplying those gives me 30. But then we should check the rest. 4 times 7.5 is also 30. 15 times 2 is also 30. So I see that when I multiply y and x, I get the same number, so that tells me it has to be inverse. So inverse equation was y equals k over x. K is what we found when we multiplied, so this function would be 30 divided by x. Okay, checking here, we could check for inverse by multiplying 2 times 10, 20, 4 times 8, 32. Okay, not inverse. Let's divide.